Hello, everybody. Hi, Aditya. Hello, Meghna. How is everyone? Yes. Yes. I hope everybody is fine. So, yes. Hi, Gurpreet. Good evening, all of you guys. Yes. Guys, today, hi, Kushika. Yes. So, today we are going to discuss about this fluid mechanics. Last time we were discussing about the properties of solid. Okay. So, we'll take a few questions today. Okay. So basically the main I'll just tell you, this is one of the very important topics, guys, because here you will be finding at least one or two questions in the paper. Okay. And from the last year statistics, if you just see, so definitely we'll get few questions from these topics. Okay. And one more thing, just want to tell you here, the main important points or the important topics in this chapter is basically the pressure, right, at any depth, or here in this the Bernoulli's theorem. Okay. And the axis pressure, surface tension, these are the important topics as far as this fluid mechanics is concerned. Few things we'll be covering in this one and in the part one, and in the part two we'll be covering few, like, other things like surface tension and other Bernoulli's and all. Okay. Yes, I am very good, guys, all of you. I am good. Okay. And let's just start off the session, right? So yes, this is the first question I'm going to take. There is a U tube, okay, with both ends open to the atmosphere, is partially filled with the water, oil, which is immiscible with the water. Immiscible means it is not, getting mixed with each other. Okay, is poured into one side until it stands at a distance 10 millimeter above the water level on the other side. Okay. Meanwhile, the water rises by 65 millimeter from the original level, and you just need to figure it out the density of the oil. Here what we need to figure it out. Let me just do it here. What we need to figure it out, that at the same liquid at the same level, the pressure would be same. Okay. So if you are just considering this one, if I'm just seeing the pressure here at this level, at the level C, so what you can see here, whatever the liquid column at this particular height, just a moment, whatever the liquid column is present at this level, above this level, excuse me. Okay. So this is the oil that is being raised here, this is the oil here. Okay. Suppose this height is h, and this water has been raised for 65 meters each, right? These are the two levels here. So together we can make it here as 65 into 2. 65 into 2, it is coming out as 130 millimeters. Okay, 130 millimeter it is coming out. So, and the oil, and it is built up in such a way that the water level is almost 10 millimeters below the oil surface. So what you can do it, you just need to figure it out how we are going to balance the pressure here. Okay. So what I can do here is, the pressure, I'm writing it here, pressure, guys, just a moment, pressure at C by oil is equals to pressure at pressure at C by water. Okay. So what you can see here is the pressure that is being like exerted by this point, this level B and C, by the oil and by the water has to be equal. Okay. So here, what is the height here? You can see here, this is 65 into 2, 130 plus 10 for the oil, right? So it would become 140. It would become 140 here. So 140 millimeter, and you can say, you can just, I'm writing the formula here, what is H rho G is the formula, right? In the case of the oil, is equals to H rho G in the case of the water, right? So what is the height in the case of the oil? That is 140 millimeter. I'm going to convert into meters here. Okay, I'm going to convert for the meters, and this is density of the oil. What would be the density here? Density, we need to figure it out, right? So I'm just writing it as rho naught. Okay, and g, I'm writing it as it is. Okay, and here the height would be 130 as we have calculated for the water. Again 10 power minus 3 for the meters, and you know the density of the water, that is 10 raised to the power 3 kg per meter cube, right? 10 raised to the power 3 kg per meter cube and into g. So how will you do it here? G will get cancel out from both the sides, and you can figure out the density of the oil 130. Just a moment, guys. 130 into 10 raised to the power minus 3 upon 140 into 10 raised to the power minus 3, right? And here the density of the water is here. So this will get cancelled out, and I'm dragging the things to the next board. Just a moment, guys. Okay, so here the density of the oil is 130 upon 140 into 10 raised to the power minus, sorry, 10 raised to the power plus 3. Okay, and density of the oil is coming out to be, this will get cancelled out if you just divide these things. So you will get 0.98928 almost into 10 raised to the power 3. So rho naught means the oil density is coming out to be almost equals to 928 kg per meter cube. This is the oil density here. So this is how you will figure it out. Okay, and one just need to tell you one thing, guys. As far as pressure related problems are concerned, you just need to equate the pressure. That's all. Okay, that's all. So everybody understood this one? If you guys have any doubt, you guys can ask me. Okay, I mean, it's not a very difficult question, right? So yes, let's just move to another question. This question is pretty good, to be frank. So there are two non-mixing liquids of the density rho, and another liquid has a density of n times of the rho, and n, it is given here that the n here is greater than 1, means the second liquid has to be more denser, isn't it? The second liquid has to be more denser because here the n value is greater than 1. So the rho and the n rho has to be greater than rho, right? Are put it in a container. The height of the each liquid is h. A solid cylinder of the length L and the density D is put in the container. Okay, the cylinder floats with its axis vertical and length. This one means rho times of the L in the denser liquid. You just need to figure it out what would be the density of that particular solid cylinder. So here you are using the Archimedes principle, where the buoyant force and the weight has to be equal. Okay, let me just make an illustration for you so that it would be easier for you to understand here. So suppose this is a like liquid here. Okay, this is the liquid here, and there are two liquids actually here. Okay, and each height is given as h because it is mentioned in the question. The height here would be same. Okay, and you know that here the density of this one is given as rho, and the density of this one is given as n times of the rho. Okay, and one more thing. Yes, this is again a 11th class chapter, guys, because fluid mechanics comes under 11th. Okay, so I do have a cylinder in between these liquids. Okay, so I'm going to make here so that this is a cylinder here. Just a moment. I do have a cylinder here. Okay, so what you can do is, here it is given to us that this length means the this one means for the more denser liquid. Here you can see the cylinder floats with its axis vertical and length rho l in the denser liquid. So you know that the bottom one would be more denser, so this length is given as rho l, rho times of the l. Okay, what would be the length of this, the upper portion? That's simple. If the total length is l, you just need to minus rho l, isn't it? Right? So if I tell you, if I just ask you what would be the weight of the entire cylinder, I am just writing it here. What would be the weight of the entire cylinder? Suppose this is weight and this is the buoyant force. This is the buoyant force that is being acted by the two liquids. So BF1 and BF2. So according to the FBT that I have made here, that would be the buoyant force provided by the first liquid and the buoyant force provided by the second liquid has to be equals to the weight of the container, isn't it? So what would be the buoyant force by this guy, this liquid at the top? So that would be that would be V rho g, right? So volume, I'm considering here the area of this cylinder would be A. So A, what would be the density of this one? This is simply rho, and length I'm taking it here as L minus rho L minus rho L, right? This is V rho, and I just need to put G here. This is the complete buoyant force that is being provided by the first liquid, that is at the top level. Second one, I'm going to consider it here that A rho, what would be the length? Rho L, and that is nothing but G. And what would be the weight of this one? That is A, area into complete length, and density into G. What are all things are common? You can easily cancel out A, G. It will get cancelled out everywhere. And in fact, okay, that's all, right? So let's not cancel each and everything at the first step, right? So because otherwise people generally commit mistakes, right? So here what I'm going to do, that is rho L minus rho square L, and we can cancel, yes, G as well, right? So rho square L, rho L plus rho square L. Okay, guys, I just did a small mistake here, that I just need to put the density of the second one would be n times, right? So here I just need to put it as n rho. Okay, so here would be n times of this one, right? Okay, and this one is equals to L into D, right? So I'm dragging the things to the next board, just a moment. Yeah, so here what you can do is you can just take out L common from this one. This is L and rho, both you can take it out. So this will become 1 minus, just see it carefully, okay, rho n minus 1 L into D, isn't it? I can just put it like in this way, isn't it? So L will get cancelled out here, and if I am just writing it here, so rho times of 1 minus n minus 1 rho, right? Okay, is equals to D. So these are the, this is the complete expression that I'm going to put it here. Okay, this is the one, and I guess which one option it will be matching? The last one, right? So this last option would be the correct one. Okay, so this is, you just need to put the buoyant force equals to weight of that cylinder, so it will balance out, and definitely you just need to put the right things in the buoyant force. Okay, and that's all. This is how you have to do it. Okay, Derivations, yes, you have to understand at least few derivations. Okay. And it's not about all the formulas every time, because derivations teaches you something, that how the formulas are coming up. It's not every time that you will be, like it will be like the question would be coming on the platter and you just need to have it. It's not like that every time. Okay. So yes, you need to understand the derivations as well for the NEET. Okay. So now we do have another question here, that is approximate depth of an ocean is this much, 2700 meter. The compressibility of the water is given to us. Okay. So depth is given, means depth, or you can say height, is given as 2700 meters. Okay. Compressibility, what is compressibility? Compressibility is 1 upon the bulk modulus, that is given to us as 45.4 into 10 raised to the power minus 11 per pascal. Per pascal means you can easily understand, because the units of the bulk modulus is newtons per meter, or you can write it as pascal. So it is 1 upon pascal, right? So density of the water is given to you, that is 10 raised to power 3 kg per meter cube. You just need to figure it out, the fractional compression of the water at the bottom of the ocean, right? Because you know that the liquid is being filled up, right, for the entire ocean. So what happens is it will be develop a pressure at the bottom. So there might be a compressibility at the bottom, right? That's what we need to figure it out. So what is B bulk modulus? That is pressure upon change in the volume. That's what you have to figure it out. Change in the volume upon original volume, that is a fractional. Okay, right? So just a moment. Yeah, so I am going to put it here as delta V upon V will be coming out as P upon B, isn't it? And what is the pressure at the, suppose this is the ocean here, this is the depth, right? So this would be H. So pressure, I can put it here as H rho G, isn't it, upon B. And you know that what would be the height is given to you as 2700, right, meters. And rho means density is given to you 10 power 3, and gravity is g 10, and 1 by b value is given to you. So I can just put it the direct value whatever is given to us, that is 45.4 into 10 power minus 11. So 45.4 into 10 power minus 11. And if you solve everything here, so this will become 3 4 5 6, and here 10 power minus, sorry, 5 6, and this will become minus 5, right? Okay, and this is 45.4 and 27, right? You just need to multiply. So almost it is coming out as 1.28 something something 1 2. Okay, let me just multiply it, because just a moment. So this is 454 into 27. So this is 37. Okay, 10. So this is 8. 12258, right? And this is the point here. So if you can use these 3 digits here, so you can put it here as 1.2 into 10 power minus 2, right? So this is the volume fraction is coming out of this, and we do have an option here, that is B, isn't it? So B would be the right option. Okay, fine. So this is how you have to do it. And I guess we do have the last question we do have with us. Yes. So what is happening in this question? Uh, in the rising from the bottom of a lake to the top, the temperature of an air bubble remains unchanged, but its diameter gets doubled. Means what is happening? There is a air bubble at the bottom, and it is being raised at the top. So what is happening? While raising to the top, so its diameter is getting doubled. Nothing is being changed, only the diameter. So suppose this is the lake. Here at the bottom, this bubble is here, this is an air bubble. While it is moving at the top, while it is moving at the top, its diameter is getting doubled. So this will become 2r, and here it was only r, right? And one more thing they have given to us, the temperature of the air bubble remain constant. So you can just tell this process as an isothermal process where the temperature is constant, right? When the temperature is constant, so you know that according to the ideal gas equation, this is PV equals to nRT. When these things all are constant, so I can write it here as P1V1 at the bottom is equals to P2V2 at the top, right? And what you have to do is, you know that here the product of the pressure as well as the volume has to be constant, and you know that the volume is pretty changing here while it is moving to the top, right? So what we need to figure it out here, that pressure, what would be the pressure here? That would be, suppose the height is given to us as h. Just a moment, guys. This height, where it is at the depth, or whatever you can say, whether height or depth, whatever, okay? So this is h, okay? Pressure, I'm talking about the pressure at the bottom, okay? H, and then we just need to take the density. Density would be rho, and this would be g, plus, you know that we do have the atmospheric pressure as well at the top, that they have given us, that h is the barometric height. So p naught, I can directly put it as only h rho g, okay, is equals to, here is nothing, only the p naught. So I can put it here as h rho g, and you know that you need to just multiply with the volume. Here the volume would be 4 upon 3 pi r cube at the bottom, and here you know that the volume would be 4 upon 3 pi 2 r cube, right? So what would you do from here? Just a moment. So 4 pi, 4 by 3 pi, 4 by 3 pi will get cancelled out, and r cube will leave only 8 here, right? So this will become h rho g plus h rho g is equals to h rho g, and it will become 8 time, right? And guys, one more thing here. This is the lake, okay? So here the density, you just need to put it as, just a moment. Yes. So this one here, whatever we just measure it, like h is the barometric height. So this density is nothing for the mercury one, right? Because we generally do the experiment with the mercury, and this is the rho for the water. Okay. So here, what I'm going to put here is h rho, means this is for the water, g is equals to 8h rho g minus h rho g. So here h rho is equals to this one, 7h rho g, and this will get cancelled out. Okay, so here basically what I'm going to put it as, density of the water, you already know that is 1, so I'm going to put it as h rho. So 7h rho would be answer. So here I'm going to mark this one as the answer. Okay, so this is how you have to do it. Okay, and one more thing, just need to tell you guys here also, you can see that there is a bit of thermodynamics part is being involved here. So it's not all the time that you have to just read out the entire chapter and you will get all the numericals from it. No, they will definitely try to collaborate different concepts. They may, put some electric field or something, they can make it, these kind of questions. So be prepared for that. Means prepare thoroughly. It's not about just reading that particular chapter and doing some questions on that. No. Okay, so guys, as far as the fluid mechanics is concerned, that's all from my side, and you guys can check out our YouTube channel as well, and this is the links, guys. You can just browse through these links. So thank you so much, guys, for the session, and we'll be meeting up in the next session with a new topic, means probably with the fluid mechanics part 2. Okay, Thank you so much, guys. Bye bye. Take care.